This is what is called an exponential growth equation. I'm going to ask you if it looks familiar at all. Does it feel like you've seen parts of this before? Doesn't that look like one of those 8% growth kind of deals? You recognize that 1 plus 0.08? Okay. So, this part is exactly like what we just did in our last project. 1 plus the 0.08, okay? And this, please write this equation. If you haven't already, write it down. And this is your starting amount. This is the rate. And this is the years. Now, I can give you a real world problem, and you can go, I can write an equation for that. Let's see if you already learned exponential equations. Not all of it, but did you get it enough? You know that scenario I just told you about? You have a baby that gets born, and we put in a deposit of $5,000 for it once. And then it grows at 10% for 65 years. Did you make the equation for that? I'll say it again. The starting amount, see, I'm telling you where to put it, is 5,000. The growth, 10% growth. And I'm going to tell you how many years this time. 65 years. Did you know that meant y equals 5,000 times 1 plus 0.10? 0.1's the same as 0.10, of course, to the 65. I told you the years too. So now one warning, if you crank this number out, it won't exactly equal what we did on our other equation, because the other equation was compounded different. Do you remember that other equation was compounded monthly, and therefore it was like divided by 12? Well, we didn't do that. So this will be just slightly different, because this one only gets compounded once per year. Once a year, you look up how much interest did you make, and so then the number comes out a little different. But it's very similar, isn't it? Okay, that's called exponential equations. See how short that was? So, sure, there's more to it. Like, let's say I start with 5,000. I want to know if it grows at 10%, when will it finally be equal to 1,000,000? So like if each American could look at their little account and it's growing over their lifetime, and it's like, ooh, it went up another 10% this year. Ooh, it went up another 10% this year. And you can look at your account. When would it hit 1,000,000? If you wrote this, y equaled 5,000 times 1 plus 0.10, but I didn't tell you how long it would take, right? Then you better put an X up there. And then what did I tell you? It was going to be 1,000,000. Where do you put that? Yeah. See how we can set these equations up different ways? I started with 5,000. I want it to be 1,000,000. How long will it take? And then you have to solve for X. All right, so just to clarify, if you haven't copied this down, please copy it now. And then I'll tell you how to solve it, because it gets tricky at the end. Did you know that to solve this equation, we got to get the X alone? To get the X alone, we'd have to divide by 5,000 on both sides. Now, you could use a calculator to do this, but there's a shortcut hack that some of you might know. If I want to, I can cancel 1,000 on the top, and 3 zeros would be 1,000 on the bottom. And then I could just do 1,000 divided by 5, and heck, I can do that in my head. Can you do 1,000 divided by 5 in your head? Say it if you know it. 200 is correct. See how I did part of it in my head. 1 plus 0.10 to the x. And isn't 1 plus 0.10, isn't that just 1.1? Yes, and we could put that in there at this point. Now then the question becomes, do you know how to solve that? And I don't think you do, because to get an x out of the power there, you have to use what is called a log, and you're going to learn those this year, but you don't know how to do it yet. So we wouldn't ask you to solve this. All right, but here's another one that we do ask you to solve that is going to happen later, and it'll be like this. X to the 6th equals 1.634. You'll have a problem like this, and they'll ask you to solve that, and I'm wondering, do you know how to solve that? Because actually, we would expect you. You can solve this. The other kind, the x and the exponent, you won't know how to solve that for a long time. But this, the calculator can solve. Do you know how to do it? All right, I'll show you. The trick is to get rid of the 6th power, you put the 6th power to a power. Does anybody want to guess what power I'm going to put it to? I think I just heard somebody whisper it. 1/6 power is what you'd want to put it to. Because do you get, if you have a power to a power, then you'd multiply. And do you agree that 6 times 1/6 is 1? And now it's x to the 1. And isn't x to 1 the same as x? So if I put that to the 1/6, I have to put this to the 1/6. And now x to the 1, which is just x, equals that. And now that's a little tricky to put in your calculator, but in case you don't know, you'd put to the power of, which is like a caret symbol like this. So you'd type 1.634 caret parentheses 1/6. Be careful, otherwise you're just going to put it to the power of 1, and then it'll divide by 6. You need a parenthesis right here. So please type that in your calculator with the parenthesis around the 1/6. You can do it on your iPad's calculator or a calculator, but try it right now. That's the trickiest thing on today's lesson, is stuff like that. Type this in. And if you're comparing with another kid in a second, and they have the wrong answer, ask them if they used the parentheses around the 1/6. I bet they didn't. All right. Check with the kid next to you, please. See if you got the same thing. So Leo, type. Just type it in. 1.634 to the power of. All right. Samra, what did you get? 1.0 what? 8.5. That's good enough. You guys get the same thing? All right, awesome. Do you get there's nobody in this room is going to be doing that problem in your head? There's no way. You need a calculator. So this next test, you'll need the calculators again. And again, you don't allow the iPads for your calculators, so definitely have one of those graphing calculators for your next test. It'll be super handy. Now, this one actually you could have done with a fairly simple calculator. It just needed to do a power. Like as long as the calculator had a little caret to the power of key, you'd be fine. All right, now let's start your homework. So everybody find the homework that is posted for today. It's a worksheet. I'll have you skip some of it. Please pull up that PDF right now. All right, it's really short, and I can't see any that aren't good. Like, they're all really important questions. Seriously, I think there's something like every one of them on the test, so can't skip any today, sorry. All right, number 1. Eric, would you read me number 1, please?
For each, for proof of
Awesome. Now tell me what is the recursive one that they gave us.
There's two. U 0 equals 2,500.
So the starting amount was 3,500. You remember where to put the starting equation part? Okay. Oh, 2,500. Sorry, I heard him wrong. Keep going.
And then
UN minus 1.
1.06.
1.06. Do you get that that's 6% growth, everybody? Okay. And then to the x, or what did they say? Next.
And
Is that it?
yeah.
Okay, then we just have to write one of these kind of equations. What was the start value? Because you always start with the start value. 2,500 is the start value. Okay. Now, do you remember that this is 1 plus 0.06? I would have accepted 1.06, but... And then what always goes right here? The years, or the time at least. Did they tell us the time? Then you put an X. That is an exponential equation. See, what do we really need? We needed the start value, and we needed what it grew by. And I know some of you are going to be like, why couldn't we just do them like this in the first place? This is way easier than all that weird U sub n junk. And that's true. But it's a state standard that you have to know how to do what are called recursive sequences, where you like say, some term is defined by the term in front of it, blah, blah, blah. That terminology, recursive sequences, is something that's in the state standards, and it's also something that could be on the ACT. So this is easier, though. To me, that's way easier. All right, Mr. Booz, would you tell me what the B part of this thing was?
U sub 0 equals 12.
Starting value, 12. Keep going.
Then UN equals UN minus 1, parentheses of 0.08.
0.08?
0.8.
Wait, 0.8?
Yeah.
Okay, so 0.8, just to clarify, do you get that that is not growth? What did I say would be really smart to always do? It still applies. I don't think you should put 0.8. I think you should put 1 minus 0.2. It's equal to 0.8, but it's better because it shows me that it's 20% decay. It's going down by 20%. Do you get it? It would be equal to 0.8, but if you're smart, do it that way. Okay, and now I'm supposed to write this equation for it. Y equals starting value, 12. 1 minus 0.2. I know, it's the same as 0.8, but this is smarter, trust me, to the x. If they told us the year, I'd put it right there. Or how many days it was, or whatever the time was, I'd put it there. All right, I think you got the idea. I know there's going to be a few that are hard because you're in honors, for Pete's sakes. There should be some that are hard. But from here, I think you got it. And there is going to be an answer key as well. Take a look at that. If you want to ask for help, ask for help.